got something really special for you.
Why'd you wait? I've been fucking sitting on my ass the last 2 hours, not doing shit. And once again, Echo, the fucking second, the literal second I sit down and start focusing on fucking something to do with my brain, and the fact that I gotta focus on something, you decide, oh, this is the perfect fucking opportunity to ask for the first time. This is the fucking great spot. Not the last 2 hours I've been doing nothing before. Get your ass over here and sit down. Sit!
Menu item, we can just check the box. You get away and give you this. At all. See exactly on inside the profile. Every
Are you bullying? You know better, Echo. So bullying.
All of this that we filtered out with a reference to everything. So, likewise. I saw today. Hopefully we'll see. Or advanced. Watch. Sometimes called depth. Also going to the nouns won't be pronounced. But here's about me.
point when they emotionally abuse blaming your relationship with your kids on your bake and blaming the cake because it burned. These grown ass parents need to take some responsibility for the
Grown ass. They don't give a fuck about what you go through or your. They don't care if your feelings are hurting you. I don't give a fuck. Now somebody else can be going through the same shit you going through, and they will find sympathy for them, but not you.
Help us determine whether or not something exists. Center. Each children supposed to be set it. Coordinate of the child. Center. If the bit is 0, find negative. Anything using binary. Visual. Count. Radar. Was the entire option that we also into a and of course his jaw. Well, from
You should
That's really all we have. The arm tree. Keep those in. The G and the H. Relations. You can an arm tree. Add that on. That let's have a you only graph. Use it automated generator. They draw off tree. It's also a draw graph. Jobs here, and we'll start two forms that we're iterating.
Sauna time? Do you need sauna? You look like you do. Come on, babe. Yes. Where you at, baby? I heard you breathing. I wanted to help. All right, fine. You go in there or something? I went under the bed. He didn't want to take a sauna.
That way, instead of intrusive function. You know, we should have found something. One more method. Starting method. But unfortunately, there's so much that we haven't yet. And as staff behavior. Producers want you to change it. Drive principle. Defines its So here, of course, we can still. There's quite a lot. It could be in a factory or a building. The arguments previously. Will create one so let's make a helper function here for that. Prefabs and figure what we want. Let's wipe out. Picking a new weapon, just get rid of it. Weapon pack. Weapon. Every factor you for now. We're just using that. start with an abstract base class. We'll call it quest message base. For now, I'm just going to pass around an ID that represents a quest. In the future, we can have more details, but for now, let's just have a start quest message. Let's have a complete quest. Each is try to handle. We're done. We can handle it. Again, it's all based on process. Again, so we finish. Let's make sure. Try to keep on. Machine setup. space class. The messages generate. And our message as well. Just make one more. Make sure it's the application. Again. Is called the or we might want to state some object. Serializable. And just that card. So of course you can adopted Blackguard and eventually experience skills. Also,
I really wish the type holder classes would override get type. I know, you're not supposed to do that because then you don't know that you're holding a type holder selector class when you're reflecting. How do we get the type in here? This is what me to pick the items. Looks like a murder scene, Echo. Does it look like you're bullying him? Your room. Echo. Room. What's that? You want me out there? I'll go spend a few minutes out there with you. You stay. You staying out there? Wasn't. Alright. Back to trying to figure out how to get the tape in here. Instead of doing that whole ass routine, fucking ass. Instead of waiting until you're desperate and sounding desperate in your bark, you can just ask. You have to walk. Be mad at me. You went to walk. You know the trigger.
now have to fight two dragons at the same time. Resist. Use the sword. And the fact that coming down, kill. Resurrecting the oh, right. It's all items. High health. Win or and gold. So let's powerful swords and trying to use the
will always be
Since it's me, myself, and amount that I know that I can. New game. Or maybe Dawn. Kind of things we want to mess. And same with registration.
If this works, I'm gonna be so fucking mad. I hate when shit like this, like, undocumented tricks like this work.
Why, look, there it is right now, and that's World of Warships. Ships is the 250th anniversary of the USA, and in this Independence Day event, live from now
I didn't think it would.
2026, World of Warships is celebrating American history and naval heritage through this lush, gorgeous, red, white, and blue narrative experience. Track with 10 stages, and you can unlock historical paintings and final reward videos, all tied to the path to American all through history, with all kinds of American ships, fancy visuals, monthly content updates, and exclusive rewards. Yeehaw! And if you play any game,
That's really frustrating. Why doesn't that work for any other situation? Why can I not fucking type restrict this? Why can I not be like, this needs to be a UI handler? Why can I just. Why?
Shooter RPG experience. So we're not talking about something my guy there. Well, let me show you then. It's definitely a guy. It's Dr. Galen. The day before we sailed, I am but I did know nature. In 1991,
I was tracing these systems. Sir,
media
Dropping sales. Who's hitting back? 1%. Stock. Sales. Of course, if
Sorry. There we go, baby. Got it.
Site. Very well remembered, despite its you sense of results was a game which had many similarities building, exploration, and collecting items. The background, top-down process, and when the point was found to be Freedom is provided through subjections to enhance the horror, which, when viewed as watching your ride, gameplay still shows its Free was decided enemies was after horror wasn't satisfying in 3D technology. Changed gaming. Just like trying to ways that
Trap, which adds a two-dimensional piece, questionable.
creative. Most interesting thing. Editing. Game. Surveillance. And switch between different camera information. And perhaps capture. And the vampire roles were just masks. Video games. Reclaiming. Curious moment about games. Horror games. Words.
Enjoy.
Trap. Just media. It. When the golden and usually 3,000,007 games. It's interactive entertainment because along with great, but it led Take-Two to create adventure games. And Dennis Hopper, or perhaps 1995's Phantasmagoria, was the F&B keys for several million dollars. An entirely game. These became leaving developers with high costs. Gloria was not a time when developers still believed. Story involved creating relationships. These topics. The future of horror would not be goals were almost as high as actors. And soon other jobs followed, including several directors. In 1993, and made the first game. Proved, however, the unsettling horror game series was on among the use of fully 3D environment. And developers experiment with 3D remote web game. Rather cartoon. It's some impressive. There was also they clearly disempowered Alone in the Dark 3 and with a wild further shows this not only an attempt more on its own. Accomplished. Its main character, Jennifer, being an almost direct copy. Like, Scissor Man. Way to point. Mouse. His ingenuity is fine. His almond is constant. We predicted. Right. The thrill of being the one. Making it high. Free. That's a copy. And it seems years of patience. Humor was
We went an hour and a half ago, but we'll go again. Don't fuck this time. fight with logs, Echo. Oh, your work keeps getting cut short. We're 3 of 3 on the same spot.
Work in all. Here. Thomas. Down there.
Somehow on YouTube, in a lot of video meetings where things made in India are pretty much, and it's a very weird kind. Not because I enjoy reading video games sequence, and it's not because intelligence, because pretty much everything. And look at the code part. Truth can be statistical truth in this case. It is, but I'm still trying any intelligence. Because the universe can think over galaxies, big galaxies. As a matter of fact, also we can think anywhere between 400 and 100 new planets. Here, even if also really told me that I gotta be never mind. And the fact that we don't really see anywhere. Here's the question is, about some of the recent including studies from export is more like statistical perspective. What interesting. Take a look at the tele- truly is. The idea that we explanations from a few decades. Scientists previously tried to mostly special. Also back in the ideas of conflict. Intelligence is both we have it for our planet and even for our sun, which will start transitioning in the next few billion years. But first, we don't actually expect here Brennan coincidence. Longer than anthropic principle. Simply put, the universe the way it is because it was different. We would not be around to see it. The possibility in such a universe would even was mostly the recent study to be yeah, that's what he said. Single fire. Simply making us, but specifically, the idea of evolution. Sometimes I also basically the unique one of it is only long, which for existence would be very specific. Summarize things. First of all, we have the here refers to it. But even though they were not in Earth as far as we have the possibly have the appearance of one and 200. There were some discoveries of decades on the and of course mostly each of these individual steps. Even if what happened was only if you were just it would suggest that things 1 in 100 here even for us, in the near future, complex like control work by it's still like more rigorous. Doing the exact 2021, I think Andrew Snyder. Quantifying just how rare these are the tiny managed to stay quantified. Actually giving us approaches. Such as and then analyze it. The more important discoveries was not the algorithmic approach, and admitting that we have no how easy or how much more these calculations show the kind of simply will that each of these figure conditions previously equal and take a record. The small difference will result that given the model discovery are inherent with the expectation that usually we could expect longer. Even if one only happen on my something. Or just the entire life. And even because this was this several times and they ran directories 99% intelligent. There's like study intelligence. First history. It's probably and intelligence collaborate. And suggest that the intelligent one. Obviously not. Scientists have tried. Example, one of the recent models researchers from the water natural conditions. And this is defined. Is defined as a real default. Driven by the condition. Go over to this case research based the case would be unstable when the condition is behind it. Heat evolution. We suddenly have in this case no longer just we're talking about something because of this idea should not be very difficult. signature and confirm it. Or if our body someone doesn't, you would have somewhat confusion, but some of the reasons were prayer couldn't really exist. That's the right. Before where that case with the realization that store or advancement seems to be another filter. That's possible. Advancing further, which is why we were not. Great filter. But versus there seems to be numbers for now that one meter. But that these really steps were 1.5. It was also can never off towards a zooms in. Your perspective. The object.
Sorry, the device name you chose, Ollie doesn't exist on your account.
Solution of theory of relativity. In part due to a fundamental tool to reveals only region of only events that solutions to Carl Schwartz. Short possible scenario. Eagles. Do it. At first. Anything would need inside the short. Farmers at the physical Cars that fit later, 19 means this is cars up to on this fun degeneracy was not far from behavior. Neutrinos stronger. This direction. And the only speedboat. In these terms here. You know what I mean? Like, and you look at that more consistent. I can see what is it fine. But negative one. And they said negative one. Southern hemisphere. Right? And Maddox says you can have maybe we should go look over the equator to see if there is something.
I don't understand
What's going on?
why you aren't self-initializing.
It was like
You should be initializing. It's only been half an hour, don't you dare ask.
to change coordinates.
This line is a constant crustal time, and it connects space and universes. See what the space far away from the event. Space-time is basically flat. This
No. We just went, Echo. We just went. You are out of your mind.
Gives you
You get one more for the night and then we're done. That's 5. It's more than any other dog in this apartment complex gets. By multiple counts. Most dogs get one when their parents go home, leave for work, one when they get home from work, and one before they go to bed. Sorry, baby. I need you to learn how to hold it. You gotta learn how to hold it. I'm disappearing soon. I'm going bye-bye. You get it?
Within weeks, and public solving important Roy Kerr, the solution for his spinning. Black hole now spherically symmetric. Spin. Simulated what? Space gets dragged around. Star. Direct. Still the black hole. When you travel in further, later the not inside the singular. Central. Independent black horizontal. Near the singular. Here. Or singular. There must be something beyond that. You venture out. Thereby, fall into the black hole. And then you can just continue.
Oh, there. And I think it's send light into the black hole because there's corner high up infinite flux of energy along its own.
Use that,
So although universes and anti-universes disappear. Seven might with wormholes used for interstellar. Able to construct. These connect different. Be able to connect different universes. Problem is negative energy density.
that theory is not the equation. Use it.
So parallel universe.
Oh, we have two.
Einstein can nothing. Physicists assume he was unable to. The experiment really does what would it take to least out
Solvay. Einstein thought that fundamentally narrow slit. Wave association called a wave spreads out through the electron is more likely to here. So far, quantum mechanics predict. Here far apart. Quantum mechanics influences across. His talk by saying this is peculiar. This implied audience member said, I feel myself in a very difficult position because I don't understand what precisely is the point which Einstein wants to make. That makes the most influential figure of time. Copenhagen. As one of his Bohr had invited as not Bohr as Bohr to find out how nature is. Anything of physics, or should Einstein to his analyzing philosophy or belief. Einstein exposed a critical reason problem. He convinced Bohr of this thought, and he was determined we will find it. Immensely probable to get around those uncertainty relations. Einstein described the purpose with action. Or, and when he recounted others, it's like
force. Einstein believed this new quantum mechanics. Imagine suddenly becomes is an electron to conserve charge. The electron restriction is into the particle.
Things wrong with imagine that the electron and proton are state good example of like measuring to just science. Listen how does it know?
Okay, max clean at sunset 1 hour is enabled.
My machine. And we can do it for any different axes the experiment. So they all percent of the time.
Now we all have to qualify. You can think of it. Choose a time. Maybe you could just do the thing. When they're done, you know, for free. Remember,
I need this as a fucking. That is so frustrating that works. That's annoying. Why does that need to be a fucking extension method? Potty?
Conceptually, pretty good if you can land.
She's now trying to work it up to ask, but instead of just asking, she's doing a 90-minute fucking routine in order to work up the energy for it. I don't respond to this. Sorry. You know what your action is. There we go. Good girl.
Situation. Last turn. That's an easy one. It can also be higher as well, starting at honest, I wasn't going to make a video about the observer pattern. Played out on YouTube. Dozens of beginner videos about the same two things, dating UI and today we'll quickly look at the basics, but the bulk of this video is going to be building a generic observer. You can observe property and field changes in play mode. And then we're going to take it even further so that you can observe values in edit mode and start building more complex tools using the Unity Event Tools. As always, don't forget to hit the like button when you learn something new today. Get into it. Let's review a basic use of the observer pattern. Delegate type is a bit like an interface. It specifies the signature of a method. All delegates are multicast in C#, which means it can hold references to more than one function. Invoked, it calls each of the methods it references in turn, one after the other. The next line declares an event named onAnyCollected, using previously defined notify delegate. The event keyword in C# essentially adds safety features by how the delegate can be used. For example, it can only be invoked from within the class or struct where it's declared, and external code can subscribe or unsubscribe for an event using the plus equals or minus equal operators, but cannot directly manipulate the subscribed delegate. People use delegates over shorthand action or func when they want to make code more understandable or documenting. In most cases, people just use func when they want to return value and this simple example, when the player bumps into a collectible, it's going to fire off the trigger. The trigger will invoke our action. Any subscribers to the action will receive the points for this collectible, and then we'll just game object. To make this work, let's just make another class called Score Manager. It'll have a text field. It'll keep track of our current score, and we're going to hit subscribe to our static event on our collectible class. We'll just have an add method. Whenever the event is fired, we're going to increase the score and update the text. Make sure that we unsubscribe to. I'm just going to move the subscription down into on and because I prefer that way. I'm going to move the updating of the text into its own method because I also want to call it on await just to make sure that the score text is going to await at the start. I'm just going to change these into expression body methods. Now back in Unity, I've already put the scripts onto the various game objects. You can see here on this collectible, I'm just going to change it to 50 points on this one, but I'll leave the other box just at 10. And I've already put the script onto my HUD with the score text. So you just hit play and you'll see how it works. Everything will hook up and subscribe to the events rate. See the score is 0. If I come over here and grab the box, then 50 points. And if we come over here to the other box, it should go up by another 10 points. Points. So that's as far as we're going to go with the simple observer. I'm just going to come out of play mode again here, and what I'm going to do is actually just disable these boxes because we're not going to work with collectibles anymore. For the rest of this video, what I want to talk about is using a generic observer of T, or type T as a private field value, but we can expose it to the editor so we can set it. And then we're going to associate this with Unity events. Let's expose T as a public property. We're going to have a special method set. Whenever we set the value, we're going to notify observers that it's. Before we get to that, let's set up a constructor for this. It needs to accept our value T and could potentially take in a first Unity action. Let's default it to null so we don't have to specify it if we don't want to. Set the value. If the callback wasn't null, we'll add that as a listener to our Unity event, and let's make sure that we initialize our Unity event whenever the constructor method. Let's say if the value coming into the set method is the same as the value. I want to keep invoke as a separate method because I might want to call it times, and it can handle some other things for us. Put a debug statement. Tell us how many events are we actually going to invoke here, and then let's actually invoke them by passing in the value. Some methods so that we can. I'll let Copilot fill in some of this, but basically do some defensive null checking. If everything's good, let's add the listener. Exactly the same thing for removing a listener. We'll make a method so that we can remove all listeners. And finally, just for the sake of completeness, let's have a dispose method. Move all listeners and just reset. Come back up to the top and actually make these set and invoke methods public so that I can call them from declaring an observable key. Let's come over to our empty hero class here, and I'm going to declare a public observer of type int. That'll be for our health. In the start method, I'm going to invoke that, so any Unity events that are defined in the editor will fire off. Let's add an update method so that I can test this out. So whenever I press the 1 key, I want my health to go up by 10. Let's do a bit of cleanup here. We actually don't need a serialized field here. One more thing, I've got a health display script already written. It just has reference to the health and a public method that we can use to change that message. Let's recompile and go back to Unity. So over here in the inspector, you can now see I have this observable health value, and it has room for some Unity events. So we can drag in our health display reference here and call its public method, which accepts an integer. I'll just come over here to my health display, and I'm going to drag that in. I can select its method. It's a little bit off screen, but it's there at the top because it matches the signature. Really it. Let's press play and try it out. So in play mode here, you can see it right away. It invoked the event, so it set it to 100. Now I pressed 1 and went up to 100 again. Keep going up by 10s every time I press the button. So at this point, you might be thinking, great, how is this going to help me out? Well, when you have behavior associated with the value, think about using an object. You'll end up with something much more powerful and easier to debug than using just the basic language. But beyond that, I want to introduce you to the Unity Events Tools class, which is going to allow us to start Unity events programmatically in mode. At the top of my class, I'm going to add system reflection and using Unity Editor.events. Now down in our public method add listener, we can add the editor directive and do some special stuff when we're in edit mode. So all we're going to do here is just use one of those methods from the event tools class during edit mode. And we can do the same thing in the public method remove listener. Now we're going to have to do something a little bit special when we want to all listeners because there is no real method to do that. So what we'll do is some reflection. Let's get the field info of a private field in the Unity event base class, which is named mPersistentCalls. The field info object has a method named getValue that retrieves the value of the field from an object. In this case, the onValueChange event object. You can then use reflection again to get the method named clear. You can then invoke the clear method on the value. This effectively will clear out the persistent calls list of the Unity event. For just sake, let's go and have a look at the Unity event base, which all Unity events. The easiest way to do that, I find, is just to declare a variable of that type, and then it'll decompile in Rider here, and here we go. You can see right here at the top, we've got our mPersistentCalls. It's private persistent call group type. So click into there and see if we can't find this clear method. A little bit down here, you can see here is, so it's not doing anything magical, but the only way to get at it, because up in the Unity event-based class, private, we need. Out of here, I'm just going to remove that declaration that I made, clean up a little bit, and what we can do now is think about how we can use this in an. I already started a class that doesn't do anything special, just overriding the onInspector GUI, following the base class. You can see Rider's even graded because it does nothing. So just a few rules before we start adding persistent events. The referencing type must be Unity Engine object. The method that we call has to be public, no anonymous or lambdas, and the parameter type has to match. Now, the reason for that is that everything that we put into the Unity event has to be realizable. In our tool here, let's get a reference to our hero, which is the target of the inspector, and let's start adding some buttons. We can have one to increase health, one to decrease health. And then what I want to do is have 2 more buttons that will add or remove a debugger. Now I've made a tiny debugger singleton, which inherits from the Unity object and has a method that will match the signature that we can. So we can have a button that will add that method, and one that will remove it. Let's just quick look at the debugger. It's super simple. inheriting from a boilerplate singleton and has a method that matches the type of Unity event we want. Okay, so back here in Unity, I'm going to click Add Debugger, and watch what happens. We serialize one of these methods right into Unity events. That also automatically added a singleton for me. Now, if I jump into play mode, right away we see that our start method invoked the two listeners, and we see the debug method as showing the correct health amount. Now I can start moving the health up and down, no problem. But what happens if I remove the debugger and then come out of play mode? Guess what? That we already serialized that onto the object, so it is no problem. That thing is going to persist, hence the name persistent. What else can we try here? Well, how about if we just clear this up again and I remove the debugger? What's going to go into play mode and see what happens if I add a debugger now. Click the button, you see it will add the debugger here, but it's not going to serialize it because we did play mode. So we come out of play mode and it's gone. So these editor methods work just like dragging and dropping. So for example, right now we could just Unity event here, and technically we could just drag in this singleton and reference the method on it. Oops, I missed it. And now we can just grab the debugger debug method again, and you'll see it serialized it just as if we had done it programmatically, and that's what we expect. One more feature I want to add to this today, and that's implicit operator. Instead of having to call health.value every time you want to get value out of the property, we can just use an implicit operator to just convert whatever our value t is right out into that type automatically. So that's just a shorthand way of saying that when we request our health property, we don't have to tack on the dot value. It's just going to implicitly convert our property into the value integer that we. Now, as an example of that, let's just come back to the hero class and add a bit of code to our start method. So we could say, in example 1, we'll get health.value, so we'll property, but in example 2, we'll just get health. And you can see already in the code hint here, it's using it as an integer. But let's see what happens when we debug this out. Is example 1 equal to example 2? And what if we just debug the recompile and hit play? So we can see that example 1 was equal to example 2, but when we just debug the object itself, it's actually telling us that it's an observer integer 32 type. I will say one thing about implicit operator, and that is it does have some overhead, so don't go throwing it there, but while it's very useful. Thinking a cool editor tool that uses this might be to observe a challenge rating on an enemy in the editor. Game designers increase the challenge rating, your listeners can configure the enemy with different strategies or gear. The only limitation really is your imagination. I think that'll have to be a topic for a future video, however. If you want to learn more about advanced game events, check out the event bus video. Hey everyone, today we're going to start talking about inversion of control. To implement IOC, you generally have two choices, dependency injection and the service locator pattern. Both of these techniques are important to understand, and today's focus will be the service locator. So let's talk for a moment about how inverting your dependencies can solve some issues in your. If you look at the code I've got on the screen, see I've got a serialized field with a reference to a serialization. Now that's one way you could do this. Another way might be that you instantiate a new serializer every time you want to use one. The problem with both of these approaches is that you've tightly coupled yourself to a specific implementation of a mock serializer. And if you're instantiating a new one in your class, you can share this serialization service with other classes and let you expose to it perhaps. Even then, in this case, you would need a hero before you could use the serializer that belongs to the hero. As mentioned, there's a few ways to get around this problem, and service is one of them. Service locator acts as a central repository we're going to need access to. So we don't have to start linking all our game objects. It allows us to do other things like get references between different scenes, register different services at object level, at the scene level, and also add a global. So without further ado, let's build a service locator. So I've split the system into 3 different classes. There will be a manager class that is going to do the storage and retrieval of the different. Service locator class will be the class that we interact with the most from our various game objects in the game. And we're going to make bootstrappers that will basically do some configuration locator of a different. I've created a few interfaces here to make some mock services. We can test out what it's like to go and look for various services from our game objects. So I'll have one here that's a localization service. All I'm going to do is make a list of words. So dog, cat, fish, car, house, and then we can send any string in here, but we'll just return a random word. So that's pretty straightforward. I think the other ones we can keep really simple. We can make a mock serializer, you know, it could be anything. Preparing something for going over the network, but we'll just have a simple method on there, serialized thing. Let's just have a play. And in our game service, just a general game type service, or we could even just call it start and have a regular start method. Our service locator class is going to use the service manager to make of them and the getting of them. Set up a separate class here. It'll just have a dictionary to store all of our services. It's going to by type. Create 2 register methods here. Let's have our first one. We'll simply accept a service any type T, and we'll get that type T so that we can put it into the dictionary, and we'll just use the dictionary method try add. Try add service. If there's a problem, log an error for that. Now we might want to register services in a fluent way, so let's just turn the service manager, and then we could chain these methods if we wanted to. Another register method, however, that would also accept the type as explicitly wanted it to be a type. Suppose your service implements several types, you want to store it as a particular type, then you could just pass it in explicitly this way. In this case, let's do a little extra error checking. So suppose that the type doesn't match what the service is that you passed in. We should probably throw some kind of error because that's an obvious problem. Also pass out the name of the service you were trying to register when the problem happened. You can also do the same operation we did above, which is to try and add it. And if there's a problem, we're going to log an error. Otherwise, we just return this and continue on. So good enough for some registration methods, but why don't we make some get methods so that we can build this service. We can do a very generic one where we're any type of type T, the inverse of what we register, but we try to get a service out of T. If we don't return anything, then we're going to throw an exception because that means we forgot to register the service that we're actually looking for. It might be more useful for us to try get method where we actually have our parameter using the out variable, and that way we can an if statement. So this is essentially the same as the method below, other than returning a Boolean instead of the, and we'll use out parameter. So that's good enough for this particular class. Let's start creating our actual locator that we're going to use to find. It's going to be a mono behavior. And we're going to be able to store different types of locators in here. The global one is going to act more or less like a singleton, but I also want to store locators that are going to be at this person. Keep those in a dictionary. Then we'll have a reference to our service manager. We'll expose our global service locator through a property. We can just say that if it's not null, we can return it. In a moment, we're going to create some bootstrapping and be able to initialize runtime if we want. Or if we fall through that, we could actually just create a new game object with a bootstrapper for this service. So I'm just going to jump up here and make a constant for whatever I would bootstrapper. This way I can replace that string down below where I just, you know what, I'm going to make one scene level 2 because we'll be using that later as well. So now if we create a game object to bootstrapper, then I can component to it. We're going to make 2 bootstrappers. One will be one that configures a 1 and one that configures a scene level 1. Why don't we do that right now, and that'll get that out of the way. I'm going to put all the bootstrapping logic into its own file. So I'll just and Every bootstrapper should require a component of. You can also disallow multiple components for this. We can have a base abstract class bootstrapper that can contain all the shared logic, and it'll be a mono behavior too. We're going to need a reference to the service locator bootstrapping, and let's expose a property here that will perform a little lazy load for us. We can make use of the or null extension method that we made back in the extensions video. And if it is null, then let's get the component off of the service locator that's attached to the object. We can also have a Boolean for whether or not it's bootstrapped yet or not. On awake, we can call a method called bootstrap on demand to see if we've bootstrapped yet. If we haven't, let's set it to true to call this app bootstrap. In our global bootstrapper, we can override our bootstrap method, and we'll do some configuration here a little later on. But here in the global one, we want to be whether or not we're going to destroy it on load or persist. Similar method for service locators we want at the scene level, and it'll just have slightly different configuration. We'll come back to a moment when we get to that part of the code. Let's jump back over there and continue. Let's use the find first object by type method and see if there's actually a global bootstrap. Find one, let's bootstrap it, and we'll return that instead. In this manner, we're kind of falling down through levels of difficulty. You know, is it already defined? Can we find one? Finally, do we have to make one? That's all we need to do for finding our global property. We're going to want one to be able to fetch a service locator for a particular scene. So what we could do is pass in a mono behavior that's looking for a service locator that's at the scene level for the scene that it's in. What we can do is do a try get value on scene containers dictionary and see if we can actually get a service locator for that one. If we can, let's return it. Now, if we can't find one in the dictionary, I'm going to make a static list here where we could all of the root game objects. And like we haven't been able to find one that's registered, why don't we see if there is one and it just because we forgot, or so what we can do is link here to say let's iterate over all of the root game objects in this scene, and if there are any that have the component we're looking for, which is a scene bootstrapper, what we could actually do is grab that component. Now, once we've got a hold of it, what we could do is just run that bootstrap on demand method call that we have a property there called container. So we can return that property, which is really a reference to the loaded service locator. So if we couldn't find a registered service locator at the scene level and we can't actually find one in the scene, we'll start using the global. Now let's go down even one more level granular, and that would be rate on the actual object. So suppose we hero component, and the hero has its own service locator component. What we can do is use a method called for, and we'll just check first of all, is it on this game object or its parents? If it's not, check in the scene. If it's not, use. That's really all of the methods that we need for locating services. We're actually almost done building a service locator here, except we don't have any publicly accessible method locator for getting services that manager. Public register methods, the ones that are in the service manager, they're just pass-throughs really. Let's start by making two private. The first one, we'll just check into our registered services and see if we can find it. If we can't do that, we're going to use another helper method that will say, first of all, if we're already at the global level, haven't found a registered service, then where there is no registered service. And otherwise, let's try to find a service locator in our hierarchy here. Look for a component in the parent. That's null, look in the scene. If we still haven't found a container that has the service locator, container is null, and we can return false. This way, we can have a public method that you can just call it get, and it'll kind of go through these in sequence. We'll try and find a registered one. Otherwise, we'll try and find one that's in our hierarchy and in the scene. If we can't find it at all, then it hasn't been registered. And one exception telling us there's a problem. I'm going to jump back up to the top here. I'm actually going to take this static list and move it up with these other static. Now, the one thing that we haven't done anything with, any logic at all when we're bootstrapping one of these service locators. So what we can do is just make some internal methods here that we call. So if we want to configure a service locator to be global, what we can say is if this one is already the global log a warning, we have a different one defined as let's log an error. Otherwise, let's set the global to be this, and we'll set the don't destroy on load flag, based on what the setting in the bootstrapper was. We need another one, a simpler one for the scene level one. So what we can do is get the scene from the game object, and we can just see if it's already been registered. If it has, let's log an error. If we haven't added it to our dictionary yet, then we can just have a little add it here. And I don't think at this time there's not really anything else to do with this. We can jump back over to the bootstrapper class, and what we can do is remove these comments now and just call these on the service locator. We can also add a few methods in our service locator to make our lives a little bit easier here, menu items, so that we could actually use context actions to create some of these in our scenes. Suppose we want to create a global level service locator. We could just have a menu item action here, a method that just we call whatever we want really. So all we really need to do in this method is create a new game object, and we can pass in the name, and we are going to global bootstrapper to it. Now, the exact same thing we can do with the scene. It's really no different except for the passing in, and we'll give it a different name, of course. Let's wrap this in some preprocessor directives because menu items actually come from the Unity editor class. Now, one more thing we should do here is statics. Now, if you recall from our event bus video, it's a good clear statics whenever you are coming out of play mode because of the way Unity handles them. It's not guaranteed that static variables will be cleared, so let's just make sure to do that ourselves. Let's also do some cleanup in case we were to destroy this service. If it's the global, let's say, found in our scene containers dictionary, let's remove it from the dictionary. So at this point, we kind of have an MVP of a service locator. It means minimum viable product. So it's not feature rich, but it will do the job. So to demo, I've added a service locator to the hero for the hero and its children local to that game object. I'm going to add a global one to our first scene here, the sample scene. So we've got a global level service here. You can see it's component as well to the bootstrapper. We can add another scene level service locator here in this first scene, and it's exactly the same as the global one except for it's in the way that it's configured, right? And then let's add another scene level locator in the second scene that has a mini-map component in it. And the mini-map doesn't do anything. We're just going to go into these classes and we'll just set up a little sample of how you would use this. Here in our hero, let's have references to store all of the services that we're going to find. Now, I'm going to register a bunch of services in the awake method. You could do this from anywhere, really, but for the purpose of this, because I want to also register services. Hero, I'm going to register them all here in the awake method. We'll put a localization service at the global level. We'll get a service for just a mock any old game team level, and at hero level, we will add a. That'll make a good. And then in our start method here, let's just say we're here in the hero and we're going to do some stuff. So first of all, you can just call our service locator and we get out the service that we're looking for. So we'll get a localized service. Then I'm going to register our mini map. I'm going to register audio service. Okay, now that we've managed to get references from our service locator for all of these different services, let's actually use them and make sure that they're working. Each of these things, if you recall, is going to debug something out to our console for us when they run. Let's go over to our mini map, which is going to be instantiated in the other scene. We're going to get an audio service. In Awake, we can also do similar registrations. We could register game service, which I'll just use a mock map service. And we'll put that at the scene level, and at a global level, we'll run an audio service. Now, in our start method, we'll do something very similar. And we'll run. Give it a try. You can see I've got a bunch of stuff out of the console here. I'll pull it out so we can have a little bit of a closer look at the order of execution here. So the hero started, and you can see our localization and then the serializer ran. The audio service that was registered in the scene also ran. And then our mini map executed, and it ran its audio service and its game service. So that looks great, but right now, all we've done so far is actually instantiate new pure C# services. What if you wanted to register a service that you had put game object from anywhere?
I want to do an actual
You know,
wall.
that could be anything
Gotta
like
listen.
a weapon system on your hero, or you
Pass
might
that
want to
point again.
register any
Not
AI or
my
something
key.
like that that actually lives on a game object in your game. So come back in here, and I've already added a list of objects to our hero.
Reset.
Serialized, we'll be able to drag in references. And what we could do is, in the awake, we could simply get the service locator for this object. And so that's going to be a service locator on this object, the scene, or possibly at the global level. Simply iterate over all of these objects and register. Okay. So now keep in mind, you don't have to register things that are quote unquote services. You could register anything that you want. So for example, I can hero into. So even though we call this pattern locator, it's really a locator of a reference to anything you're looking at. It could be this capsule collider, health component on my hero, or this mana component. I've added a little debug statement onto source locator to see what types are being read. If we take a look in the console here, we can see one by one it was read. Collider, component, and the mana component. Before I ran this, I removed all the service locators. You can see in the Don't Destroy on Load section, we have now a global service locator, which has registered all three of these components. Technically, right now, our other scene could actually get a reference to the capsule collider on our hero if we want. Service locator is powerful and flexible, but some people consider it to be an anti-pattern because it conceals dependency. You also need to ensure that you have correctly registered the service you want to use before. Locator pattern also means that every class that uses it now has dependency. In an upcoming video, we're going to talk about dependency injection and frameworks you can use, which is a more powerful form of it. Thanks for watching, and I'll see you in the next one. When I want to expose several systems through a single interface, I use the facade pattern. Here's an example. I'm using 3 tools in to control visual effects. When my player moves from place to place, kind of cinematic occurs, I want to change the effects. What I don't want to do is call several methods and change properties every time on all of these systems. You might be doing this with weather systems or audio systems or anywhere else where you have operations that affect an entire subsystem of objects. This is where the facade comes in. Today we're going to create a facade for 3 effects to create complex visual styles, just one method call. Well, you could use any combination of subsystems behind a facade. Here I'm going to show you how I would combine regular post-processing effects with the unique features of Beautify 3 and oil paint assets to create some unique visuals. So as part of this system, I've created a few different volume profiles that have different style effects I want to have. So we've got really basic ones here. I've got an artistic one that doesn't do too much because I'm going to this one. The horror one is going to slightly change the color a little bit to a bluish color. It has some other features like chromatic aberration and depth of field. Created a movie volume that just has head motion. And then I've also created another volume that has Beautify. The Beautify, of course, has so many settings you can choose. Only set some of them. A little bit more bloom, anamorphic flare. A little bit further down is a new feature of Beautify 3, which is the ability to have. So what I'm going to do is have horizontal bands on the top and bottom of my cinematic sequence. I'm going to go ahead and create an empty game object here that'll just hold a bunch of buttons that'll interact with our facade. I've already created an empty script that'll hold our buttons, but let's also create one for the facade as well. It's going to be a singleton, and I'll move it into the file here. Our facade is going to be an interface between the different post-processing setups I want to have and the rest of the game. I have some public methods here that will hide the complexity of how these systems work. So these three methods here will form our public API. Any button or trigger or other event that needs to change the post-processing needs to call one of these public methods. Like in the buttons class, let's define 3 buttons, one for each of those public API methods. I'm going to use Odin here, so I'll just define a color quickly, and then button attribute to create a button for each one. I've got the first one written here. I think Copilot should be able to take over. It already knows what I want to do. Go set up cinematic, and set up artistic into Unity and make sure these look correct. Drag the buttons component onto my game object here. Yeah, there we go. That all looks great. Okay, let's carry on, and we'll start with the first. Now, for each one of these public methods, I want to load one of the volumes that so we'll store that into its own. We'll run a method that will. All we really need to do to initialize a component to it, we need to load. To actually load the settings into the volume, what I'm going to do is create a new class here called resources utils, and it's just going to have an extension method called load volume profile, resources.load method, and loads into the volume. So now we can come back. The first part of each one of these methods will be to load one of these created methods in here for those. Perfect. Now we can test it. So back over here, I'm just going to add the facade to the same game object. You don't have to. And press play. Oh. So we've got the colorized cinematic, nice and crisp with a little more bloom. And the artistic, not much different than the cinematic yet, but we'll be changing that in a moment. It's doing exactly what we want. It's loading all the profiles. Come out of play mode and keep going. So the two other systems I want to implement are Beautify and Froncon Games Oil Paint system. So what I'm going to do is make 2 classes that are going to control those, because they're a little bit more complex than just volume. Move these into their own files, and we'll work on them one at a time. I think what we'll do is actually start with the Froncon system first. So I'll create a reference for that so we can store it here, and another initialize method in start, and I'll set the system for us, basically very similar to already. We'll just create a new game object. We'll add our new component to it. Then let's jump over to the new and start writing it out. So this is the first time I've actually used the oil paint one. So what I did was went in demo, and I copied a little bit of code from there, and I'm just going to change it a little bit. I'll import the dependencies here. Let's add a variable so that we can keep a reference to the settings. On awake, we can use a method of the class already to get the. Then let's just run another method called initialize. Initialize will handle this, everything we want. Paste rating. You see, I've the intensity to be 0 because I want it to start. I'm going to set when to insert to be after rendering this. A quick look inside of this settings class. You can see there's quite a lot going on here. You can see there's a lot going on here. This is actually quite cool. I'm starting to really like it for one day. So let's clean this up. We need one method here that's going to change the intensity for us, so we can a toggle Boolean on and off. Let's call it is active. It's active. Let's set intensity 1, otherwise 0. So we need to turn this effect on and off. Let's come back to the facade. I'm going to move all the initial stuff, keep it at the bottom. And so in each of our public API methods, what we'll do is we'll decide painting effect on or off. So the only one I actually wanted on. That done, we can actually hit play here, and let's stop again, make sure everything's working correct. Or yeah, let's want. How about artistic? And there we go. So now we have a cool hand-painted effect whenever we want kind of an artistic render of something. And I've got it turned up to pretty much the max. It's definitely worth playing around with it. Next, let's add Beautify into our mix so that our facade can control the
Not
different
okay.
Beautify settings.
You
If
know
this
better.
video is
Come here.
useful to you, give it a helps YouTube share it with more people, and it gives me feedback that it's useful for you. I'm just going to add a few more using statements. See them in a moment. And for Beautify, what we can do is store the Beautify setting similar to what we just did for Hong ones. I'm also going to add a little bit more functionality here to make it a little bit more useful in the future. I might want to access the settings of Beautify from a public property. We can also use a null coalescing assignment operator just to make sure that there is something actually in there. When we go to initialize this component, I will have already loaded our Beautify onto this game object. So what we can do in Awake is we can actually grab a reference to that volume. Let's iterate over all of the components, find the one that is the Beautify component, and return that one. We're not using this one from the Beautify set, actually on this game object. And if for some reason we don't find it there, let's just log in. You know that, but that should be a little bit more robust and it'll get us local to this. The setup I want to do in this class, but now let's start adding some utility. What if we just wanted to turn off Beautify altogether? We could just have a disable method here that would turn off the, let's see, it's called active. Yep. Active equals false. And we can start toggling settings or actually just turning them explicitly on and off. I'll just make some room here. I'm not going to make methods for every single Beautify setting because there's probably hundreds of them. But basically, we can just start with blur on and off. On and off sharpen. Yeah, we could. There's two vignette settings actually. There's the outer ring and the inner ring. Just toggle them. Come down here. Let's make some activate ones that'll actually accept the boolean. We might as well do vignette first. So this is just basically the same except we'll assign a Boolean value. Looks like I got a typo there. Just fix that. Okay. How about we do the cinematic bands? Now that one I've already configured it on the volume. So all I really need to do is turn it on and off. On the volume, that setting is called frame. All we have to do is turn it on. Probably enough for our little demo. I think I'll just do a little bit of cleanup here. Once that's done, we can jump back over to the facade. Now we need the initialize method for Beautify. We're going to do something very similar to all the other ones. We will create a game object for it. We're going to add a volume component to it, and we'll load in the specific Beautify volume that's already. Then we need to add a new class to it so that we can control it. Move this down below with the other initialize methods, and then we can put it to use. So let's keep it super simple for now. In the horror settings, I don't want any bands, but I do want the vignette. So let's turn the bands off and on. Now I'll just copy and paste this down to cinematic, but I actually the opposite. I want the bands on and the vignette off. And then finally down in artistic one, I actually want to turn both of those things off. So I'll just paste it in there again and switch cinematic bands off. And then we should be good. And then just before we go back to Unity, I'm going to quickly add one more thing for outline because I want to use it in the horror setting. I'll have a toggle in and activate, and I'll turn it on in horror, but off in the other two. There we go. All right, let's jump back to Unity. So if I hit play now, we'll see all three systems will load up in the hierarchy, and we've got a pretty nice looking screen right now. And through the buttons here, horror is going to work the way we think, but cinematic now should show us our bands. So that looks pretty awesome. It's got all the Beautify effects and the regular processing. That looks awesome. If we come over to artistic, of course, it's going to give us our oil painted look again, and we can just toggle between these as we like, and we can hook them up any way we want in code now. And that's the real power of the facade pattern. We don't have to worry about all the complexities of managing three different systems. We just have one method to call these styles that we want to player. So just to make this a little bit more robust, I'm going to add our component of type volume to our Beautify system. And I'm going to add one more extension method here. And I'm going to put this in the repository for the extensions. For some objects like this, we just want to hide them from the hierarchy because they're hidden behind the facade. We don't care about them. We're not really going to interact with them. There's sometimes you're going to want to interact with them, but for the most part, it's kind of set and forget. You go through the facade and you don't worry about them. So let's just hide each of these in the hierarchy as we're initializing them. let's just have a quick look at what we've come up with here. We've got basically a facade with 3 public methods: setup horror, setup cinematic, and setup artistic. The rest of your game really only needs to know about these 3 methods, and that's it. That's as simple as it gets. I'm just going to say one last thing, and that is, do not be tempted to use the facade simply to hide your messy code from the rest of your game. That's not what it's for. Tempting as that might be, the facade is really just to provide an easy-to-use, friendly interface over top of complex stuff. That's all I've got for you today. I'll see you in the next one.
I've been exploring options for managing all my flyweight pattern. Flyweight pattern aims to minimize memory usage and improve performance by sharing as much data as possible with objects. All my fireballs, for example, share the same prefab and their values, and this data is an object. What would be nice is to combine the utility of the flyweight pattern with Unity's object pool class. What I'd like to do today is create a simple but powerful factory. Not only create our flyweight objects, move them in and out of their own object pools as well. I'm going to start by defining a simple flyweight class containing a reference to the intrinsic settings. Intrinsic values are by all. So we can define all common values in a scriptable object of the flyweight settings. Going to have a reference to the prefab, then a few more values that'll work for my projectiles that I'm going to set this up for. I'm also going to have a method in here that will create a flyweight for me. So I can instantiate it into a variable here and set active false. I'm going to make sure they're all named the same, and I'm just going to name mine after my prefab names. I'm going to add the flyweight component to it and set the reference to this. I can return the object. I'm going to add a create asset menu attribute. This is really all the shared data. I'm going to move this into its own file. Then I can come back to my flyweight class and just going to add some really basic functionality here, test it out. So while the flyweight is active, I want it to be always moving straight forward. So I can grab the speed from the common settings and just every update move it ahead a little bit. Then we'll despawn it after. Now despawning is going to mean actually destroying it. I'm just going to wait for a certain amount of time, and we can set that on enable, and then we'll destroy it. In on enable, let's just start a coroutine here. So I'm using a helper method here and I'm actually storing them in a little dictionary. I'm going to go take a look at it. So instead of creating a new wait for seconds every time I want one, create it the first time, store it in the dictionary. The time I want one afterwards, I can just back in my settings. I'm also going to add an enum here for types of flyweights. This will be useful when we start doing our flyweight factory. I'm just going to make 2 types for now for this demo: fire and ice. A property here in the flyweight settings, and that's about all we need right now. If I jump back over to my hero class, I can put a little implementation in here so we can start testing it out. A public list of flyweight settings here. In our update method, we could check for some key presses, and then our flyweight settings can create the flyweight for us. We can just character and turn it on. This is a very naive implementation, but it's really just for testing. Before we go back into Unity, let's also make sure that it's rotated the right way. So back here in Unity, I can start defining some scriptable objects that will contain all of this shared data for each flyweight. The first one here could just be for fire and fireball particle system that I want to put onto here. So drag that into here. And I think the default values for the other things are okay. Now I'm just going to duplicate the fireball, and I'm going to call this one Frost because the prefab is actually called Frost Missile, so it's fine. Drag that in. Now the hero just needs references to both of those objects that we just made, and that's really it. Once those references are in there, we can. I'll just zoom in a little bit here and let's see how this super basic is working. Yeah, we got both types here, pressing 1 and 2. Problem. So this is okay, but it's not really that useful. Still destroying the flyweight, run out of time. Garbage collection. I don't really want to start managing individual object pools for every type of flyweight. So what would be really nice is to create a simple factory that will manage all of this for us. We call that the flyweight factory. I only want to have one flyweight factory, so I'm going to use a version of this keep an instance variable. And then I'm going to start leveraging Unity's object pool. An object pool for each type of flyweight in a dictionary. So to maintain the singleton in awake, let's just check to see if instance was null or not. If the instance was null, let's set instance equal to this. Load, otherwise we'll just object. In a moment, I'll create a few public methods to act as an API to this. We're going to need a private method. So when we pass something in here, we need to know which pool it actually belongs to. All of the flyweights have a reference to their settings, which can type. Use that to find the pool this object belongs to. In the settings, and we'll try and get the pool. If it exists, we return that pool. If it doesn't exist, then new object pool. Let's create a new object pool of type 8. The constructor for a basic object pool in Unity takes in 4 callbacks and 3 values, so I'm just going to put each one on its own line. We've already made a create method. The create method is a func returns the same type as the pool. Other callbacks are all actions. We'll be able to keep those in our settings. The last 3 values we can just define in our factory. Get all these code hints out of the way for a second. So we've got create, and then we've got actions that fire on get, on release, on destroy, and we've got 3 values for each pool that we want to create. So up at the top of the class, we can declare serialized fields for each of the primitives. Finish up that private method, we need to add this new pool to our dictionary. Then we need to return the pool. So let's set up these action callbacks. On get, we just want to enable the object. On release, we'll do the opposite. And if we were actually going to destroy them, we can just actually. Right, our factory is almost ready. We just need some public methods so that we can interact with them. I'm going to make 2 static methods here. One is going to spawn a new flyweight. To do that, the consumer just needs a reference to the settings script. Let in, then we'll get the pool for those settings, and we'll actually call the get method on the pool. And we'll basically do the inverse of that when we want to return a particular flyweight to the pool. The flyweight has a reference to its settings, so it knows what type of pool it belongs to. Call the release method on that pool, and that's it. In the hero, we're not going to create flyweights ourselves anymore. We're going to call the flyweight factory spawn method, pass in the settings for the one that we want. Both references here. Then we also don't have to set active to true anymore because we already have a callback for that. Last thing to do is we don't actually have to destroy these objects anymore. Instead, let's just call the factory's return to pool method and pass this. Back in Unity, all I have to do is create a flyweight factory here. We'll just add the unit here to the new game object. Just down a little bit so we can see a little bit better. So now if I start pressing the buttons here, you should watch these things start to create themselves and stay inside the pool. There we go. So they're not being destroyed anymore. And now if I start casting again, you can see some of the existing ones start activating again, and then after a little bit, they go back into the pool. So this is a very simple implementation of a flyweight factory, but it really only makes one kind of flyweight, which is a projectile. It would be nice if we kind of separated the flyweight logic from the projectile logic to make any kind of flyweight, maybe a tree or an enemy. There's really 2 ways we could go about this. We could extract an interface, or we could extract a base abstract. So both of those methods have their advantages, but the interface would require using generics, and it would get quite a bit more complex. The simpler way to go here is use an abstract class. I'm going to pull out all of the projectile-specific logic into a new class. We'll just leave the settings in the flyweight. Now, our intrinsic data for projectiles is probably different than any other. So let's jump over to the settings class. Make a new class that is flyweight settings. We'll just call it projectile settings. As we continue to develop our game, we could more values in here. For now, Copilot suggesting damage. I'll move these other projectile specific settings. all of the methods virtual. That way we can override them from the base flyweight settings class if we want to. Let's create asset menu attribute here and move this into its own file. Now if we jump back over to our new projectile class here, we've got a few things that can't be referenced. And that's because flyweight settings in the base class is casted into the projectile settings type. We need to use the keyword new here because we're using the same variable name. Alright, just a few more references to change. Back in the hero, we're still referencing flyweight settings. Really the projectile settings to enforce the type here. Just change the variable name to be projectiles. That's all we really have to change there. We come back to our projectile class. Because it's a model behavior, it needs to be in its own file. I'll move that over here. And then one more thing, we should really override our create method in the projectile class because we don't want to add the flyweight component to it. We want to add a projectile component to it. I'm just going to copy and paste that same create method over into our projectile settings class here. And we'll change this to an override and we'll change the type of component that's being added from flyweight to projectile. Now in the future, we'll be able to add any more custom logic we want when creating projectiles here, and we could override the other callbacks as well, and other behavior when spawning or spawning, etc. Alright, well let's jump back into Unity and just make sure that I didn't break anything. Play and start shooting off some projectiles. Looks good. Looks really good. Just make sure they're going back into the pool properly. Yeah, perfect. Well, I hope that gives you a few ideas if you're looking to manage the spawning of objects, but I'll share some. I'm still weighing the pros and cons of using interfaces instead of a base class. And I'd like to key the pool dictionary differently. Let me know what you think in the comments below.
Get in here and say that to my face.
Jesus assassin.
Singleton is the most common game programming pattern. But are you getting the most out of it? Today I want to go all the way from the basic C# singleton through all the variations that I've used, right up to the null object singleton. We'll talk a little bit about the null object programming pattern, and I want to demonstrate some of the new features of C#, such as default interface methods. Lots to talk about today, so let's get into it. As per usual, let's start with the basics and gradually get more and more. If you need to enforce the constraint that you only need one of something, you don't need to expose it to the editor, and consider making a pure C# singleton. You can store the instance in a private field and then expose it with a public property. If the instance is null, when someone goes to fetch it, you can just create a new one and store it there in your private field. Prevent future you or anyone else from just creating a storekeeper anyway to make a private. The way this is set up now, the only way someone can create a storekeeper is by calling for the instance. Now, this isn't a whole lot of code, and me personally, I would move this into like I'm going to do with the model. So let's move on and look at something a little bit more complex, where you actually want to expose your singleton to the editor. So again, this is so simple that the pilot was able to fill it out later. Unlike the pure C# singleton, here we can hook into the Unity lifecycle. On the wait, we can check if there's already an instance assigned to be the singleton. If there isn't, then this instance becomes the singleton. If it is already on, let's just destroy this game object, and that will enforce the instance of this. For me, this is already too much forward. I like to keep 3 variations of a generic singleton around, so I can just into that whenever I need. The simplest of those is just a singleton of type T, where T is a component. You have just like fields to hold the instance. Now, I like to keep a few public methods here that come in handy once in a while. As instance, we'll be able to tell
I'm so hungry, I need a damn dog.
A try get method might be useful. In the public getter, I'm going to add a little bit more resilience here. We can say if the instance is null, let's use Unity's find any object find. This retrieves any active loaded object of type T that exists in any of the loaded scenes. If we still can't find one, Let's just make our own. Instantiate a new game object, and we can add component of type C to it. I'm just going to change the name here so that we see that this was auto-generated. That means we either chose not to place one in the scene or we forgot. Now, if we did place this item in our scene, when the game starts up, the await method is going to get called. So then we could initialize the singleton. Now, await can get called in some situations in edit mode. So we put a check in here that says, if the application isn't playing, return. Otherwise, let's set instance equals to this as type. Here we go. We've got a simple generic singleton that hides away all this boilerplate for us. Now, another variation on this is the persistence singleton that destroy on load. It's almost the same as this, so I'm going to create a new class and we'll just copy and paste this in, and then we can just make some changes here. Now, one thing about don't destroy on load is it only works on game objects at the root level. We're going to have a Boolean flag here that will be defaulted to true, that will auto unparent this object. If it was parented, it's a child of something, we want to kick it back up to the root level. So what we can do is, when we're initializing, we say if this flag is true, let's set it to be null. Then I'll add one more conditional here. I'm just instance assignment up into there, and we'll add our don't destroy load flag. At this point here, we can also say if the instance wasn't null, then we need to destroy it to this instance. So I would think that up to now there haven't been too many surprises. What I want to look at next is what I call a regulator singleton. First, I'm just going to copy and paste this persistent singleton code into the regulator singleton. Called it a regulator singleton because it's self-regulating. What it's going to do is find any older singleton instances that happen to exist and wipe them out so that it becomes the one and only singleton. I'm going to make it a little bit leaner. We don't really need to unparent this one because we're the ones going to be instantiating it. We probably also don't need to try again. You can make these any way you want, they're just examples. I'm going to also add a hide flags to this new game object because I don't want it ever getting saved with the scene. It basically destroyed the one that was supposed to be in place of it. To accommodate all of this, what we should do is have each of these singletons keep track of when they were actually created. So with those changes at the top of the class out of the way, let's go down to the bottom here and take care of the real life. So we're done with auto unparent on awake in this class. Let's go rid of that. I'm going to use don't destroy on load out of the conditional here, and I'm also going to at the same place set the initialization time. So you can just use find out time for that. Now, right before we make the assignment at the end, we're going to search and destroy any other existing instances of type T, so we can just wipe that part right out. Now let's just create a little array, and we'll find all the objects of that type. We can use Unity's new method here. Copilot's suggesting the old one, but it's been replaced by this find objects by type, and look for type T, and then you pass in sort mode. It doesn't really matter which sort mode we use because once we've got them all in the array, let's just loop over them one by one. We can each T old in old instances. Get the regulator singleton component, find the initialized time. If that one's initialized time is this one's initialized time, destroy that old one. Then at the end, we make the assignment, we should only have one singleton. So that one's a little bit different than a lot of people have probably seen before. So this kind of system might be useful if you want to totally swap out one game system for another one at a certain point in your game. Like maybe something's happened where, for example, maybe you're going from your UI to your gameplay. You want to get the UI sound system out and put in the new gameplay sound system. Okay. And we make an example just like that. I'll have an audio manager. It's a regulator singleton. It's not going to do anything. It's just a dummy class so you can see how it works. And now I'll also make an audio spawner. And this could be maybe put on a game manager or something. So let's just make a component that will have prefab in it. And when I do something like, let's say I press the 1 key, it will spawn in the new prefab audio manager. Let's go into Unity and see how that works. So let's suppose in my scene here, I've already set up an audio manager. I'll make a prefab like this so we can spawn another one. I think maybe we'll skip it differently, and maybe I'll just call the prefab new audio manager. It'll be very clear in the hierarchy when we. And the one that's in in the scene, let's add the honor here too. Got it. Now when I press play, you'll see that the audio manager goes right into don't destroy on mode. So it's going to work the way we want. When we want the new one, I'll press the 1 key and get rid of the old one and put in the new singleton. That's the ins and outs of building a regulator type. Will replace what's ever in it. Basically, the regulator is the inverse of the persistent. Will destroy any new instance. Regulator 1 will destroy any old ones that already exist. Last thing I want to talk about today is null object singleton. Now, I'm not going to cover everything there is to know about using the null object pattern in this video, but a null object is often very well represented by a singleton because a null object does nothing. A null object has the visitor pattern was the toughest pattern for me to learn, and I know a lot of people feel the same way. Today, I want to show you how I learned this pattern, and I hope that it will help you too. The visitor pattern started to click for me when I began to visualize it more like an alien visitor knocking on my object door, wanting permission to come inside and interact. Today's video will take us through implementing a power-up system using the classic visitor pattern. We're going to touch on intrusive and reflective visitors too, and we're going to dig a little bit deeper into null coalescing operators and get into it. Visitor pattern relies on something called double dispatch. And I just want to explain that really quick here. In object-oriented programming, there are many times when the method call can't be decided until runtime because of polymorphism. The concept of dynamic dispatch comes in. It's how the program decides which method to execute when there are multiple methods with the same name. Single dispatch is based entirely upon the object type. Double dispatch, which we're going to be using today, is based on the object type and the argument type. Don't worry about that too much. I just wanted to put that out there in case you read that somewhere and aren't sure what it means. After we define our interfaces and a few concrete implementations, it should start to all come together. So we need two interfaces to make the visitor pattern work. We need an interface for the visitor, and we need an interface for the object that's going to accept the visitor. I'll just move each of these into their own file, and then we'll define our first concrete iVisitable, and that's going to be a health component that we'll put onto the player. So we'll define this as a mono behavior and implement the iVisitable interface. And I'll let Copilot fill this in here with the accept method. We'll accept the visitor and then allow the visitor to visit this. And let's add a debug statement there. And I'm going to make another one very similar. We'll call it the mana component. And it'll allow the visitor to visit the mana component and debug a message. Again, because these are mono behaviors, just put them into their own file. Now let's turn our attention to the visitor. I'm going to get rid of this little placeholder because we need to define specific implementations for what we're going to do when we visit the health component, when we visit the mana component. So with that done, let's define our power-up, which is doing all the visiting. We'll make our power-up a scriptable object so that we can make multiple types of power-ups in our iVisitor interface. It looks like Copilot has this figured out exactly what I want, including the debug statement, which is perfect. But let's have a create asset menu here, and I'll just file name, and then again this has to go into its own file. Now we just need a way for our hero to be able to pick up this object in the game. So let's make another class. We'll just call it pickup, and we can put this on all of our little objects in the game. It'll be a mono behavior. Copilot already knows. On trigger enter, we're just going to see if we've collided with something that can be visited, and if it is, then we'll allow that visitable object to accept our visitor, and then we'll destroy it. Let's come back to our main player. We'll implement the iVisitable interface here. We're going to keep a list of all the components that are on our hero that should be visited. I'll just call this visible components, I think. We'll add the health component and the mana component to our list here. And that way, when we accept the visitor, we can just iterate over the list, and the visitor can go and visit each component in turn. Now, I'm going to use the get or add extension method that we've used before on this channel, and we're actually going to dig into that a little bit deeper. But for now, come down into our accept method, just looping over everything and then calling the accept method on each of those components. Just before I forget, I'm going to jump back over to the pickup script and move that into its own file. We can come back into Unity, compile, and some scriptable objects. Let's start by defining these scriptable objects. So I'll start with a health power-up, but I'm going to add a little bit of mana onto it too, just so that we can see that the visitor is visiting all the components. So I'll put 100 health, and let's just leave mana at 10, that's fine. Let's duplicate this and we'll make one that just does mana. So we'll put a mana power-up. For this one, let's put in a 0 health bonus. Let's do 250 just so it's different. Now, our hero needs those two new components. Component and a mana component. We can leave them at the default values here. Fine. And we need here. Let's come over to these that I've got here. Each pickup is going to need the pickup script, and then it's going to need a reference to our scriptable object. Health one into this one, and then on this other sparkly one, add the mana power up to that one. So now we're ready to go. That wasn't very much code, was it? Let's give it a try. So first, let's visit the health pickup here. So you see right away, the power-up visited the health component, and the health component accepted it, and then it visited the mana component, and the mana did. If we jump over to our hero, you can see we now have 200 health and 110 mana, like we expect. Jump over to the other one. Now again, we can see all the components were visited. Now, while our health has stayed the same, our mana jumped up by 50 more points. So that, in a nutshell, is the classic visitor pattern. Though this didn't take a lot of code, visitor, in my opinion, is still the hardest pattern to learn because it can feel like there's circular logic. For me, I had to do an implementation that was similar to what we've done here today, just my head around it. To put it all together, I was really able to see the power of this pattern. Next, let's have a look at an intrusive visitor. Visitor is just moving the logic from the visitor and putting it into the things that are being visited, so our components. So let's add public methods to our components instead of allowing our visitor to access these public properties. Change this mana property here. So I'm going to get rid of the public, change the case of this to lowercase, and I'm going to add a hidden inspector tag, show an inspector. See it? And let's do the exact same thing on the health component here. New method here, just to add health. Now our visitor can't touch these public properties. Or to our visitor power up there. And so instead of changing these public properties, I'm going to call these public methods. That's really all there is to the intrusive visitor. So let's hit play and give it another try. Let's pick up the health one first. And so you can see all the components have been visited and stats on our hero are exactly the same. And we can expect the same thing here. Perfect. Works exactly the same way, but we've moved the logic around. Whether or not you want to do that, it's a design decision and you might have other constraints, but that's the intrusive visitor. Okay, let's jump back to code. The next variation I want to look at is called the reflective visitor. Now, imagine if we reach the point in our game where we have 20 different components on our player, for example. We would have to implement a visit method for each one of these, and that's where the use reflection to try and find a method called visit on the current class using getType, which has a parameter type that matches the type of object O exactly. Now, we'll check to see if we found a matching visit method, and if it isn't the default method that accepts an object parameter, then we'll invoke that visit method and pass in object O. Amazingly, Copilot has written this somewhat difficult method correctly. Add a default visit method here. It's just going to do no op and we'll statement. And then just so that we can see that it's working, I'm going to comment out the mana component call here, the visit call. Now let's fix up our visitor interface. We only need one method now. Visit an object that's like reflection will do the rest, find the method that we want to call. Let's try it out. So now, whenever we try to visit the mana component, we should just run that default method. So, over here to the health one, and yeah, you can see so the components accept the visitor, but when the mana component accepted it, it just ran the default visit. And if we look over at our hero, yeah, we can see the mana value didn't change at all, but the health went up to 200. We visit the other one, now nothing happens because there was no health value to change, and the mana component simply ran the default. Benefits to this, of course, is that we have a small interface. So the real benefit here to the reflective visitor is that our interface is super. Now, I'm just going to uncomment all this and run it just as I normally would. And so make sure the reflective visitor is working the way we think. But while I'm doing that, one more thing to consider is that there's a bit of a performance hit, and some people will argue that using reflection in your runtime could be dangerous, and it can be. So I just wanted to put this out there for consideration. You may see this out in the wild, and when you do, you'll know what it is. And if you want to use it, oh, now you know how. Now, just before we jump into the next section, don't forget to hit that like button if you learned something new today. I want to take a closer look at the null coalescing operators and our get or add extension method and how that can solve a potential problem. This problem stems from the fact that Unity has overridden the equality and inequality operators in the Unity Engine.object class. That means instead of deleting something right away, Unity simply marks it for some point in the future. Null coalescing operators in C# cannot be overridden, and that's where the problem comes in. In this first example here, I haven't assigned anything to the animation. Then I'm going to get component and assign it in there, and then we'll destroy it immediately. After each of those operations, let's just see if it's null or not. Let's jump back in here and press play. We should see null, not null, null. So that's behavior exactly like we would. Okay. Good enough. Let's look at the problem now. I'm going to remove this code from the first example. We don't really need that. I am going to assign the component and then destroy it. And I'll uncomment this second. So here, we've destroyed it. Let's put a new animation manager onto the game object. And then let's try to use the null coalescing assignment operator to get a reference component. What do you think is going to happen? Guess what? Object is null. The problem, because the frame hasn't completed, the Unity equality operator is going to tell us that it's null. The null coalescing assignment operator knows that it isn't actually destroyed yet, so it's not going to assign our new component into that variable. So let's look at this third bit of code here. I'll just get rid of everything else. We've now destroyed that component, and we're going to use the extension method get or add. So now we can correctly see that the object is not null, working as. That's the problem in a nutshell, really. If you're destroying game objects or anything that inherits from Unity Engine.object, and you start using null coalescing operators to references to it, you could run into some trouble. So last week we were fetching components, but we had a required component attribute of the class. That means that the component itself, which is required, can't ever be destroyed, or the reference is never going to be. But it's not apparent, or it's not super obvious. Just better way is to use this extension method. Let's have a look. When we run this extension method, we're first going to check if we can get the component from the game object. If it's null by Unity standards, that means marked for deletion. Then we're going to add a new component and return a reference to that. Okay, I think that's enough heavy topics for one day. I hope the visitor and a deeper look at null coalescing Unity will help you out. Knowing is half the battle, after all. I've been toying around with some new assets here too. Do you see those shadows on the ground in my scene? That's the new Cloud Shadows asset from Chronic. It's on sale right now too. I'll put a link to it in the description. Don't forget to hit that like button and subscribe. More interesting topics on the way to help you apply engineering patterns and principles to your games. I'll put a couple related videos up on the screen, and I'll see you there. Today we're going to look at an implementation pattern that solves a big problem for us. Unity devs were always looking for ways to communicate between components and game objects without needing them to be aware of each other. As a software engineer, I often implement the event bus pattern to solve the problem in the real world. In this video, we're going to build an event bus system for Unity and also bootstrap it on game load. Along the way, I'm going to explain each of these Unity and C# techniques. At the end, you'll have a powerful messaging system to use in your projects. Let's get into it. The system will have two parts, the event bus and its events, and then the code that will bootstrap and configure the system when the game starts. Create the event bus first. Let's start with interfaces. All events in our system will implement the iEvent interface. The iEvent binding interface will represent a relationship between action and an event of type T. We'll have two public properties. Action we add to the binding could either use the event type as the argument, or it could be in the concrete binding, I'm going to store the actions in private fields and will expose them using an explicit interface. An explicit interface implementation will enforce the requirement to store bindings as the interface type and not the concrete event binding type. See that when we declare new bindings. Now, I'm also going to store an empty delegate into each of these events so that they're never null and we don't have to waste time with null checks on them. We can also write this in shorthand. So, declare two public constructors for the binding. The first one can pass in an action with a parameter of type T and assign that to the onEvent variable. The other can pass in our noargs action and as well. All right, I'm just going to tidy this up a little bit with some and a couple more public methods here so that we can do more actions or remove them if we want at runtime. So after we've declared an event binding with one action, we decide, oh, we want. We can just do that. So about everything we need related to bindings, I'm just going to move all the binding related classes into their own file here, event binding. Then we can come back here and start working on the actual bus. So our bus is going to be the hub of activity for. We're going to store all of the bindings related to a type of event, and we'll put all those into a set. We have two public methods to register and deregister a binding. And we'll need a public method that will accept the event and invoke both the actions on the binding. Normally, there will only be one action defined, but recall that we assigned empty delegates already, so neither action should be null. I'm also using the @ symbol here, so we can use the event keyword as a variable name. This isn't really necessary, but I wanted to show that in case you're not sure what that means. Next, I want to start working on concrete events. I'm going to create a new file called events, and I'm going to call event. We don't need too much here, but I want to have a couple that we can test with. Let's have a test event that has no data. Let's have a player event that sends around a little bit of data. So we will be able to Unity. I'm going to use structs over classes because structs are allocated on the stack, not the heap, and so it'll put way less pressure on the garbage collector. Over to our hero. Now our hero will need two bindings, one for our test event binding and one for our event binding. And we're going to need to run some methods when those events get raised. So really simple ones that output some debug statements. So the first one, the test event, isn't going to receive any data, so we can just debug a statement, but the other one will receive a player event, and the player event has. Let's output those to the console as well. Okay, now on enable, let's define the bindings and register them to the event bus. Pilot figured that one out, no problem. But let's also make sure to deregister from these events on disable. One more thing before we leave the hero behind for now. Let's define an update method where a few key presses, which will raise these events. So whenever we press a key, it tell the event bus, raise the event, and any bindings that have been registered to that bus should fire off. Okay, so at this point, we've basically written all the code we need to working event bus, except you may have noticed one thing. We haven't actually defined any concrete types of event buses. And that's what we're going to look at next here. What we're going to do is bootstrap this system up by looking through these 4 assemblies that Unity puts together when it's compiling your project. There are 4 total, 2 for runtime and 2 for the editor. I'll link in the description to these docs. Now, before the game even starts running, we are going to find every type of event in these assemblies, and we're going to create a bus for them. Include your own assembly definitions, but you can add them to the tool. I'm going to split this into 2 parts. First, let's make a tool that will search through these assemblies and find all instances of it. I'm going to define the assembly types as enum because I don't want to make any spelling mistakes later. When we're searching through the assemblies, we're going to get the values back as strings. So we can just relate those to the enum types and use those enums going forward. What I'll do is just make a little method here, translate string response into an enum value. A switch in here that will return the correct enum value based on whatever string we pass in here. Looks like Copilot has that figured out, so this looks good. Remember, it could possibly return null because Unity isn't going to compile any of these to compile. You didn't have any editor scripts for those editors won't even exist. So moving on, let's have a method where we pass the type of interface and we get back all the list of concrete types. In our case, we're looking for all the events and we want a player event, test event. First of all, let's grab all the assemblies from the current domain. Now we need a dictionary here so that we can store all of the types we find in each assembly and associate it with one of our enum values. What we'll do is we'll just iterate over all of those assemblies. As long as the assembly isn't null, we'll add every single type we've found into our dictionary, and we're going to refine that search in a moment. Okay, now that we have a good organization of what types were found in which assemblies, let's make a helper method that will further refine our search in all those types, in reference to the type we're looking for, and it'll have a result. Call that type. Be represented as a selection, and that's what we're going to return when we're done. So I'll just come up here, private method, it'll take in those arguments. Then all we do is make sure that the assembly containing all the types isn't null. If it is, like there's nothing inside, fail out. Otherwise, let's just iterate over it. And if we find one that matches the interface we're looking for, let's put it into the types collection, and we'll just keep populating that with what we find. Here, if the type wasn't the actual interface, like it's not iEvent, use the method isAssignable to make sure it actually implements the interface. If it matches those criteria, it's going into. Class was somewhat complicated, so what I'm going to do is get the JetBrains assistant to quickly write up some for this. Put this in the repository, and if you guys are looking at it later, it'll have all these. I need to rearrange my arguments down here. Okay, now for the really exciting part. I'm going to create a new class that'll hold all of the utilities for our event bus. Move it into its own file here. It's going to need references to all of those event types that we just found using our other tool. We just make it in a only list. And we can do the same for all of the event buses that we're going to create. So what we're going to do here is use a special attribute that lets us execute code before our game even starts. Runtime initialize on load method. Here you can specify when you want this thing to actually go off, and we're going to say first scene load. What we're going to do is run a method, initialize, get all of those types using our static method that we just wrote. Then I'm going to initialize all of the buses in a different method. So this next method here will just return a list of types of creating. Let's store those in a private variable first. I'm going to also store the type event bus into a variable. And then I'm just going to loop over all of the events we found and use the make generic type method from the type class to create an event of each type. So that means we're going to make an event bus of type event bus of type player event, and so on. Before we leave here, let's make one more utility method that we're going to need, and that all we need to do here is iterate over all of the buses we made. Let's use reflection to find a method on it called clear. Clear, we'll have to write that in one. Empty out all the. Let's jump over to the event bus class and just add. Very simple. I want to add a little bit more functionality. A quick little cleanup. When we come out of play mode and back in, we should ensure that each bus that we've created is empty. This will remove any potentially unresolved references to objects, which would prevent them from being garbage. Could lead to a memory leak. During these bindings when play mode.
To do this, I'm going to use another attribute called initialize on load method. This is just like the runtime version, except it's for the editor. So if we put a variable that knows which state we're in, listening to the play mode state on the editor application, when that goes off, we can register our state, and if it is exiting play mode, we'll clear all the buses. Might as well get JetBrains AI to write up a bunch of documentation here. I'll read over it and make sure it's all correct, and maybe add some links right in too. And then this will be in the repository. If there's one thing that AI is really good at, it's very good at writing. Compile the code and click to play, and right away you can see it's initialized both the buses. Now if I click the A key, there we go, test event received. The player got the message. If I click B, yep, we get the event with both my health component and play mode, and right away we can see it's clearing all the buses, test event bindings, and the working as expected. Do one more test. I pulled in these sample orbs from Chronic Liquid Volume 2 package. I want to use them in my UI for Mana. Now I've already written a little script. As you can see, this is very similar to our hero. We've got a player event binding. We're going to define it on enable and register it. On disable, we'll deregister it. What I'm going to do is bump up by about 10% every time. I'm just going to come back into Unity and add that game object. I'm going to hit play and start clicking the B key. You can see my health orb starts filling up by 10% each time. I'm still getting the messages, player event on the hero. I had a lot of fun creating this. Add more features to it in the future, and I'd like to hear your suggestions in the comments. Maybe in a few months we can revisit this topic, create an even more powerful event bus based on your suggestions. There will be more advanced Unity videos like this in the future. So if you want to see more content like this, don't forget to like and subscribe. I'm also going to put a link up on the screen to my video about event channels, another powerful way to decouple your game objects in Unity. Make sure to check that one out too. Have that option available. Most requested videos on this channel and to build an inventory system. Here we go. Today we're going to procedurally build the view for this inventory system. It allows items to drop, will display a stack indicator, and it's going to allow us to drag the entire around the screen. We're going to do it with UI Toolkit, but using code, not clicks in the UI Builder. Two different ways of doing drag and drop using UI Toolkit. The second way is going to be to implement a UI Toolkit manipulator. Lots to do today, so let's get started with a start by taking a quick look at it. I've got a setup very similar to the video from 2 weeks ago about a view, a controller, and a model here. In the Unity editor, we're going to expose the entire system through a monobehavior inventory that'll into the controller. The controller is going to have two-way access to the model and the view. So the model and the view are going to publish events. The controller will make all the decisions about what's going to happen in the system. I'm going to design my system in such a way that there are clear seams in between each of these parts that really should be its own. I'm going to focus on one of those, which is that you build this system in such a way that in the future, if I decide I don't like UI Toolkit anymore, I want to use UGUI again, or I want to use a better system, Nova, should be able to replace this entire view module, whatever system I want. So today we're going to focus on just this one little area of the view. We're going to procedurally build our UI and everything it needs for. Today we're going to build everything with code, but if you want a primer on using the UI builder that comes with Unity, I'll have a link to this excellent video from HJ at UI Motion Video. We're still going to need an empty UXML document to act as the root of our visual. You can get a new one by going to Create UI toolkit. I'm just going to call mine inventory, and then I'm going to open it up in Rider. Take a look here. You can see that there's quite a bit of metadata with this UX. Most of it is unnecessary. Document also has a space of engine. If we jump over to one of these samples, this one comes from QuizU. They're using a namespace of UI and have completely different metadata. Now, we could actually go with the bare minimum, which would look something like here. I don't have a namespace at all. So I think what I'm going to do is actually jump back to my inventory UXML document, and I'm just going to strip away pretty much everything. Editor tools, so these lines here can go. We can bring this line and we can get a version declaration. Now, unless you're going to use UI Builder, you will never make changes to this. I'm going to do everything procedurally and just use this as the. If I come back into Unity here, go on to my empty inventory game, and I'm going to add a component. And that component is going to UI document. You can create your own panel settings asset by going to create UI toolkit asset, but I've already got one, so and we also need a reference to the UXML document that we were just working on. For UXML document, you probably want to also have a key. So you can get one of those by going back into the Create menu, to UI toolkit again, and select. I'm going to call this the same name as the XML document, and I'm going to Rider. Here we can see it just has one element defined with no style at all. And before we start writing styles, and since we're not using UI Builder, just make a little diagram of what we expect to accomplish. Let's draw out all of our visual elements by one, closest to the root. So at the very back of this pile, I'm going to container that'll just stretch the entire width. And then the child of that, we're going to have our actual inventory. Now the inventory is going to be between the container and all of the slots. So we'll be able to put a background image on it. But absolutely positioned over top of the inventory, I want to have a frame and another little background image with the words inventory on it. Frame, and on the other one, I'll just header. The header can be its own visual element, but we can have a child as a label, and then we can easily change the text. I'll make one more visual element here that will slots container. So it'll just be basically a wrapper container around all of the slots and help them function properly above the rest of your visual elements. Slot is going to have to contain a bit of logic, so it is going to extend a visual element and be its class. And that's just because all of these other ones are kind of dummy. They're placeholder stuff. Slots themselves need to contain a bit of logic so that they can react to pointer events. I'm just going to stack these up here in the view in the order at which I expect them to appear. And this will make sense as we start to procedurally assemble this tree-like structure of the elements. The slots will sit at the very top here. Still one more thing that we want, and that's a little icon that we can drag around. Once we've selected something, we're going to make a little ghost icon that will be most of the time invisible. Once we've made a selection for dragging one of the slots around, we're going to fill it up with an image, and then necessary. Storage view is going to be the basis of this. I have an array that's going to slots within their storage unit. Today we're just working on inventory, but we're going to have more. I'm going to need a reference to the UI document component as well as that. Next, I'm going to have some references both for the root and for its child, the container, just so it's easy to make queries later. It's nice to have a reference to these. Next, I'm going to create an abstract method here that will be responsible for creating our tree of visual elements. I'm going to pass in an argument with a default size of, already the inventory I want now is 20. If I use it for my hotbar later, I might want to pass 10 or 6. Now I'll kick this off with a coroutine in start, but in the future I'll run it from the controller once the inventory system is fired up together. Really enough for our storage view for now. Let's extend it with the inventory view. Get rid of this red squiggly here by implementing the initialize view. Now the initialize view is going to do everything required to set up the visual tree. Initialize our. Because we're going to have a label at the top of this particular panel, I'm just going to expose it as a string to the field. The first order of business here, let's just define our array as a new array of size that we. Now from our UI document, we can get the root visual element and assign that into the root variable. And I'm just going to run root clear here. That'll clear it out every time we decide to do. In case we're also going to have a reference to the style sheet, so let's apply root. And we can begin constructing the rest of the tree. So we'll start with the container, the one that's going to go away across the screen. I'm going to use the extension method createChild. This extension method and several others that I'm going to use have been discussed thoroughly on our Discord channel that you're welcome to join. I'm sure we're going to have lots more interesting and there. We go and take a quick look at those extensions. The main purpose of all of these custom extension methods is to make it so that we can chain methods together and have code going on when we're constructing. Able to create children and attach them to parents. Two methods for that. One is specifically for visual elements and one is any type T. We're also able to add a particular element. We're able to add CSS class style to a visual element. And if we scroll down a little bit here, we can also add a manipulator to a particular. We'll get to manipulators towards the video. Code will be in the repository for you to have a look at afterwards as well. Keep going and make the first child of our container, which is going to be that inventory. So we can create a child on the container and give it the style inventory. The inventory is going to have two children, which will be absolutely positioned. Frame, and then on top of that is going to be the header. The header is going to have its own child, which is a label. The label will have that final name of inventory. Next in the order will be the slot container. I'm going to make it a child of the inventory and give it a style. Now we can iterate over the size and we'll create a new slot that will be a child of the slots container that extends visual element. Just like a visual element, but it's going to have some additional logic for us. Give each of these a class of slot, and then I also want to keep track of it in my slots array. Now we're almost finished building our tree. If we take a quick step back and just look at this whole thing, you can see that we're assembling it bit by bit with one thing becoming a child of the next. We're giving most of these things their own style name. We're going to get to styling in just a moment. Now let's have a look at this slot class that extends visual. I need each slot to know a little bit of information, but it doesn't really need to know much about an actual item. It needs to show pretty pictures to the user so they can click on them and move them around.
No, we're
So
done
it
for the
needs
night,
to know
Echo.
an image to show.
We're done for the night.
To show a stack label. So if we're stacking items and we have a count that's greater than 1, I want to be able to show the user how many are there in the stack. I'm going to make use of the index of method that elements, and visual element also has a reference to parent, and this parent, being the slots container, only contains slots. Index of method is actually going to give us the correct number of the slot within the slot container. So the first one is going to be 0, and it'll go all the way up to 19. Now for convenience, we're also going to pass in a little bit of data about what should be shown here on the screen. The first is a serializable GUID that we're going to get to in the next video, just representing the type of item that this is. The other is going to be the actual sprite that comes from the item detail as well, and that's because image and sprite are not really the same. I need to apply a texture from the sprite to the image, so it's useful for me to store a reference to that. In the constructor, I can create the other visual elements that we need. I'm going to create 3 of them. I only need references to 2 of them because the one in the middle is that's going to sit over top of the image, but underneath the stack count. Finally, we need a way to actually set this from the controller so we can put our dummy items in here for, and we'll, of course, during runtime, we're going to be set and unset. So we'll just have a method here called set, and that'll accept our serializable GUID, the sprite, and the quantity. Should it be different than 0? So we'll set the item ID and the base sprite. That's the only data that we really care about. Then we're going to set the icon image. If the base sprite is not null, let's get the texture from that. Otherwise, it's null, no image to show. And then we can say the stack label text. If the quantity is greater than 1, let's quantity in there. Otherwise, empty string. And then we'll decide or not also based on whether. Now we should also have a method just to clear this out, and all that needs to do is set the ID to empty. No, that's it. Now we should probably do something about our ghost icon too, because we're going to want to apply a little bit of styling to that as well. So if I come over here to the storage view again, I have a static visual element that will represent the ghost icon. Now we can initialize this when we're initializing the rest of our tree. So back here in inventory view, I'll just add one more line so that we element be initialized as a child of the container, and I'm going to give it a style name called ghost icon. I'm also going to use the bring to front method. This method makes sure that a particular visual element will be in front of all of its siblings. Okay, so we've got our whole tree constructed. Why don't we have a look at it and see what it looks like without any style at all? So back here in Unity, I need to add that inventory view to the inventory name object. Once I've got that in there, it needs two references. The first one being this UI document. Drag that reference in there. Then it needs a reference to that empty style sheet that we're going to start filling up. Now, additionally, I also need the inventory component itself that has all the wiring, controller, and the model view together. And that's going to provide our starting items, which I've already created. So I'm just going to drag a bunch of them in. And I want a couple extra ones just so we can test the stacking as well. Maybe I'll grab one. That should be enough to get us started. But what happens when we press play? Find out. So all of our items showed up in a nice column. That's great, but how do we know without any styling that the structure is actually correct? Well, Unity actually has a tool that is quite good, and debugger. Within the debugger, there's a button there called pick element, and I can choose something from the screen to have a look at. So now I've selected my entire tree here, and I can have a look at the exact structure of it, where the classes are applied, and break it all the way down here, right down to the stack label. So it looks good. I can see my ghost icon way down there at the bottom. Since this looks exactly what I had envisioned, let's start applying a little bit of style bit by bit. Just by way of review, let's come back to our UXML document. You can see there's nothing in here still. It's just the root. There's nothing else and never will be. Now, over in our empty style sheet, let's start working our way from the very bottom, which would be the container, and we'll go all the way to the topmost element. So the container is going to cascade its styles down to everything else. So I like to put things that I'm going to generally want set. Flex scroll 1, we want the width and height to be auto, no maximums. I'm just going to have the column will be the default. We're going to justify everything vertically and horizontally into the middle. I've chosen a font that came with this asset and referenced it here as our default font for everything. I'm going to drop a little shadow, and then I've also chosen the color yellow. You can see in the column there, right, showing me what the colors are as well. Now I'll go on to the inventory. The inventory is going to show our background, which is the hidden panel. I want it to be a fixed size. For me, I know that I want this inventory to be 300 pixels wide and no more than 500 pixels. I've added a little padding there just so I can keep the contents away from the edges. Let's go have a look in Unity. We've got our wooden panel showing up. We can now see the words inventory there, even though it's in the wrong spot. But you know what? It's not bad. Keep going here. Do something about that text. So for the inventory header class, I'm going to position it absolute. I already know exactly where it is. Remember, absolute positioning is relative to the parent, not the whole document. So it's relative to the inventory, not container or anything. So I know the positions. I want it centered. I've got a nice background image I'm going to put under this. And now take note of the last thing here, the Unity slice scale. When you're using 9 sliced images, they may sometimes be wonky if they're too big to fit what you're trying to do. You can scale them down or up using this attribute. Now I'm going to add one more thing here for the label. I want the text to be. Get out. Now notice I'm still in play mode. I never came out of play mode. I just come back into the editor and hit Control R. I can see my changes in real time. That's one of the beautiful things about it. So that's looking pretty good. Let's keep going with the styling. If I come back in here, I'm going to add the inventory frame. No surprises here. It's almost the same as the header, just a different image. And let's do a quick check. Control R. Pretty good. Let's move on to the slot container and the actual.
container needs to be down from the top a little bit. So I've added some padding there. It needs to wrap and it needs to go in rows, starting from the top left corner. So flex start on the alignment. Now, each slot I know I want to be a specific size, 60 by 60 with a margin of 4 around them. Each slot has a frame on top of it. It needs to be positioned absolutely. It's the exact same size, positioned from the top left. And I already have an image to go into that. And next down here, we have the actual slot icon. Now, I'm not going to specify a size. I just want it to fit into the slot. Now, the frame that came with this GUI asset has little rounded corners. So I want to add a little bit of padding just so that my images of my icons don't stick out past the frame. But when we pull them out of there, they won't have the padding anymore. So it's going to look kind of cool if they're just a little bit bigger. Let's have a look at how we're doing the drag and drop links. So I'm going to register a callback here on pointer down events. So when the player clicks this slot, I want to publish an event.
Echo, be good. You don't bully him. No, baby, we're done for the night. You have gone out 6 times today. You don't need any more. Is that Asuna from SAOA?
Never.
Why didn't the converter register? First UI. It does have one. Daytime offset to stream, yeah.
You can talk. Well, barely. Are you okay?
Moment. Now.
Yes.
your baby.
You're welcome.
All that. I said I need bloody rules. Today's mother said, why he
and you choose the free. Then she bows according to her. You opted to not much back to your camp. But it ensures that the rules of the deleted. The most frustrating extreme monkeys and throne. Allowed to let it get the problem of when somebody goes to the party or all of a sudden. No matter what her when she was a little car. It almost chose immediately tried to handle it. Not and I didn't use her. Oh, that could have. Read a night. Data. It just sounds. Barely. Dialogue trees. Teacher and the dialogue. Her to be a. I don't need to find the goddess. On her own. On her bench. That was the night. Oh, not too long ago. Let doing that. They don't really need to let me do that. People are simply and like they're gonna see this possible encounter, of course, to a question needs to be We use very I feel I didn't like leave immediately. Because she was stuck in my way. I left the that basically mind player. You know, true. Maybe it's worse. I'm playing this about the to use more than one wisdom check. You have to pass. Taking that to get not take it. You're manipulated. You want Baldur's Gate 3 in full ever ever. Because you're being seriously. Hate this. Hate that they are not into a mind. bought you some. Difficult to all the information. As someone who's really paying attention, yeah, he's got the violence his own accord. Forbidden the bomb in his chest. And we later find out was to begin with because it had been eating. He all brought all this on. He actually literally says it when you more than that. I really can't say, oh, this is the intentional piece. Humility 2 years ago. Not they plan to say, will do the same. So there has been some to avoid trouble with yourself. Really sad. Now, if it wasn't you in your class, you would have learned first as if the crown is not close. That he's the only paying attention close from learning that to do something of all is the most magic. I important to note how Gale does and he plays it. The code is default and for the very moment. I'll get to why. That being said, how would you and use against the trash can of Wizard Lord? So there's a lot of things here, especially when he's leading towards that feels my opinion. Something's on from the book. visit and you see the you're certain the truth. Always use it because it's been corrupted. The one you call the dream visit. No, it didn't. Fight you. This is also a of the cost doesn't count the dream visitors. Long enough to be able to reward and value. all the info. By their deity. Ascending. All the game. Undying queen. Leads to further godhood of someone else. Things, and of course it all the way around. His own Vistra was literal.
From low copy. Coming. See, please. I kid you not. All kicking. The pop bomb. Not right. Use to collect. Cool aspect. Yo, wait. Alphabet. Hey, Ryan, the cool headed. Comboing and then two, so it You have the enemies. They are after you, so they will actually halting your progress back on. Combination of ways you can use the vault. And the hindrance to your platform. And the options. It's great. Mechanic time. Really important. It's different. Right, something where you get faster way. See. During the long you take. You get from the yeah, headshot. Was be really interesting. How they act. Levels design. Replays the level. They will have different that are even further through these different algorithms differently. Writing buttons of time. There's less than 2,000 than most. Anyway, one GTE. Moving arrow. Use the triangle. Which needs to be tricky possible input flying across the screen. To get overwhelmed. Practically. Like you're actually feeling of being realize you just now the game also has direct I've seen just had to act in Tokyo. God game and God game side you have the other side the overworld, which are the humans of this game. Work to generate those things but for those things really during sin more sins you can make from them. Too many sins they could become buildings like creating different players to solve. If the temple falls due to being attacked, you lose. So mana, use spells in Pokeball is super important. How to protect you. Traps are important. Depending on they might make them work different crops to generate different things. be aware of the ruler. Additionally, building the human are more direct way to use our resources. They need a healthy. The zombies population is dwindling, so less people. The for the make here is to focus on it's the concept. You're not on. This edgy. This edgy. It works like mitigate. Bring through by that. Don't just really shine. Firstly, there are very little restrictions to player sensitivity. They can tackle a lot of the problems. Well, every culture bullet hell. Doom is all ripping and tearing. Moving above. Maybe attacks moving towards fans. So they can a lot of people those warriors. Cool mechanic. Defend this side. This one is different. What the players do, there's no however, but what's special Okay, quick before I've gone forever. Mechanic of the game is all about. When heaven door inside. Door. Look around the I'm sure 100%. What's it? Basically, it's that. Cool. Web something quickly. Then I carried it across the ceiling to the side of the thing. Finally, I got hold of it. It's really clear, very innovative. Unique ways. One cool thing I can make. Comment. Dispose of it. A brief break. We have essentially the solutions as well as to make the system tackle systems just work. As a concept of revolution, a rockstar such as the system allows to move around, which is
One cool mechanic in works. This Vampire Survivors inspired roguelike stage rock. You get XP, supply all you at the end of the run. I bother during the level. If you level up, the reason why this is therefore to a mid-round crystals early themselves motivate you are low on right back to full. We'll pick up with they fly to you then not to get into the decision you will be making. You then have to either send them to their lifelong patient. You can quarantine how their symptoms help, or you can switch. The gameplay decision is totally guess. Your decision affect how much money you get. Right decision, more money. Make the wrong decision, get less. Locations like I mentioned. Just how bad their situation. Not right now. Sending someone to they don't wrong do at some point, and the game is balanced really well around surprisingly. Play this game. You really simple. Bring a lot of the Match 3 game might they break. You have walls, rocks, and forest. As a perfect brokenness in what this feels during the battle phase. Farmers more when you break. When the battle you do actions when including farmers. Farmers to be also enemy units breakwater meaningful. Eat from farm yourself. With a balance. Find decisions around all of the base and act battle. The enemy bases go pieces around. Honestly, this is marathon is just pain point due to genre management, having items. These usually clog up the inventory. But in particular is fighting battle. Expo you don't have set on by default. Items on automatic. Or just the art of cool mechanics in and of itself.
do not. Until you've done this. Through the rough. Use the new drawing. Go down thick. Hands on. You go down. Contain the brisk head. Side of the the foundation of the simultaneous play is you'll probably just make off. Cool. Let's start with this incredible. Matrix of the suspect in mind of getting them as comfortable as possible. The offensive, you want any hope of getting do this by would be so which of the both don't. Instead they give you content orientated on career. It will give you this information. Which style options are suited to get them time to pick how to get the suspect be ready to be a confession with the
Yo vengo frío. Mira. Oh, vengo frío. You're a goof. Fucking headbutt me. Why isn't this binding working? The manipulator's working.
can't find